Alright, so today we're going to be talking about different types of chemical reactions. There are 5 major types of chemical reactions. We've got your synthesis, decomposition, single replacement, double replacement, and combustion reactions. So pay attention to what reactants you start with so you'll be able to predict your products. Why? Why is it important to be able to predict the products of a reaction? Well, if you were working on a research team, that's your job. Okay, your job is to save money and your job is to do it safely. So what you basically would want to be doing would be predicting the products of your reaction, proving that what you think is going to happen is actually happening, and then testing and seeing, okay, we thought that, say, 30 grams were going to be produced. Are 30 grams actually produced or just 20? Okay, where's that extra 10 grams going? Why? Okay, so that's what research teams actually do. All right, so let's talk about the 5 major types of reactions. These are types we're using as a very intro level, first year chem. As you go through your chemistry experiences, you'll learn different types, okay? But this is for the very first year, 5 major types that we're going to be talking about. First up is your synthesis reactions. So synthesize. If you think about synthesis, it's something that is created, okay? It's something that you make. So synthesis reactions are going to take elements, more than one element, so 2 or more elements, and they're going to combine them together to form one product. Okay, so if we created a general equation, we would have A plus X yields AX. So I'm going to let you know what that means, okay? So the A is talking about any cation, so like a metal. And the X is going to be an anion, like a nonmetal. And when they combine together, they're going to form a compound, okay? So an example of that is like shown up here. We've got A, our metal, which is sodium, plus Cl, our nonmetal, yields AX, table salt, our compound. Okay, so 2 or more elements that combine together to form one compound are going to be synthesis reactions. Next up, we've got decomposition reactions. Decomposition reactions occur when one reactant breaks down into multiple products. Okay, so this could be 2 products, it could be 3 products, it could be a lot of different things. For right now, we've got a basic equation and you can apply it later. So we've got one reactant breaking down into multiple products. And the word decompose is hidden right in there. If I've got a decomposing body, I've got a body that's breaking down, right? Probably not so pretty, okay? One body breaking down into all the parts, okay? So if you look at the general equation, we've got AX yields A plus X. So a compound, right here, one compound breaks down into several components, okay? So this is AX yields A plus X, right? So that should give you an idea of how something decomposes. Next up, we've got our single replacement reaction. This is where it gets a little bit trickier. Okay, so for this one, you have an element and a compound that rearrange themselves. Okay, one element is going to swap spots with another element. All right, so if you have a metal, it's going to swap spots with the metal in the compound. So if you look right here, we've got A plus BX yields AX plus B. I'm going to apply it to this equation up here. Mg is a metal, so it's going to be an A. Ci, Bx yields B, Ax. Okay, so this magnesium swaps spots with the calcium. It moves in, calcium gets pushed out, calcium is by itself, magnesium bonds with the oxygen. Okay, that's what a single replacement does. One goes in and swoops in, swaps spots with another, right? The general equation is A plus Bx yields Ax plus B. If it's your nonmetal set switch, that's fine. Bx plus Y yields By plus X. Okay, you have an element and a compound, one switches spaces, all right? In your double replacement reactions, you're going to have 2 compounds where the metals actually switch spaces, okay? So the metals swap partners and bond with the opposite non-metals. So if you guys look at this, I have one polyatomic, which is OH, so keep an eye on that, and that's going to be your X. AX plus BY yields A, Y, plus Bx, and that's your formula for your double replacement reactions. Two compounds are switching partners and they're replacing the other one's similar atom. Okay, so the metals swap spots. Or if you want to think about it, you can think about it, the non-metals are swapping spots. That's your double replacement reaction. Again, it starts with two compounds as a reactant. You get two compounds as a product. The last one is your combustion reaction. Your combustion reaction, you're going to start with a hydrocarbon. Okay, so it's important to know what a hydrocarbon is. A hydrocarbon is a compound made up of only carbons and hydrogens. So think of it as C question mark, H question mark. Whatever numbers are in the question marks, that's fine. But if it's only made up of carbons and hydrogens, then that's called a hydrocarbon. Okay? So a combustion reaction is a hydrocarbon, like the one here. This is a hydrocarbon. And oxygen, like right here, react to form water and carbon dioxide. Every single time, hydrocarbons and oxygen will form water and carbon dioxide. It'll be in different proportions, but it will always produce water and carbon dioxide. So if you see a hydrocarbon and oxygen in your reactants, you know it will produce water and water and carbon dioxide. Okay, and that's your combustion reaction. So just to leave you off, remember that in your synthesis reaction, you start with two elements creating one singular compound. In your decomposition, you start with one reactant forming more than one product. In your single replacement, you have an element and a compound starting out in your reactants, forming another element and a compound. And in your double replacement, you've got two compounds forming two compounds. And then last, you've got your combustion, which is going to be a compound and an element. It's going to be a hydrocarbon and the element of oxygen that form carbon dioxide and water. Okay, so it's actually going to be a compound and an element forming two compounds. So that one's a little bit different. You have to keep an eye out for it. The other ones, you just gotta know, gotta memorize. All right, I'll see you tomorrow.